Okay, section 12.6 is all about properties of logarithms. So like I said at the end of the last video, this is where we're going to be diving into our properties of logarithms a lot more, moving between logarithms and exponentials, and even solving some equations. We'll continue doing this again in section 12.7, 12.8, solving more equations. So for this section, there's really only one thing, and that's to be able to use the properties of logarithms. Properties of logarithms. So if we're going to use the properties of logarithms, we have to know the properties of logarithms. Logarithm properties. Some people call these the log laws or the log properties. They mean the same thing. It's just how logarithms interact with each other. So we are going to let x, y, r, and b be positive real numbers. And we need that for all of our properties. So number one, these are ones we saw last time. So log base b of 1 is always 0. Number two, log base b of b is always 1. And number three, b to the log base b of x equals x. Number four, log base b of b to the x still equals x. So these are the ones we saw. We also had the last one about the 0, but we're not going to write that here. But these are the properties we saw in the last section. So now we have some new ones. Number 5, log base b of x to the r equals r times log base b of x. So when you have an exponent on a single term inside the argument of the logarithm, you're allowed to bring that down to the front, is usually what we say. This comes down in front of it. And remember, these are equalities, so you can go in either direction. If you have a constant on the outside of a logarithm, you can bring that constant up as an exponent here. So this is a very useful property. Number 6 is log base b of xy being multiplied equals log base b of x plus log base b of y. So we call this the product property, or the sum. It's the product sum property of logarithms. So if you add two logarithms that have the same base, you can combine them into one logarithm with that base where the arguments of each are being multiplied. And similarly, log base b of x over y equals log base b of x minus log base b of y. So this is the division and difference property. If you have two logarithms of the same base that are being subtracted, you can combine them into a division of the arguments with the same base. And of course, you can also go the other way. If you have a division of arguments, you can always split that into two logarithms being subtracted. So these aren't the only properties of logarithms. These are just the most common and the most useful. There are a few others that I know of. They just don't get used that often, or they're just combinations of these. So we can combine any two of these as well. So what I'd like to do now is give you just a whole bunch of practice problems. And I just want you practicing using these properties. So I would like you to condense / collapse the following into one logarithmic expression. And I have 4 for you to do work on. The first is log base 6 of x plus log base 6 of x plus 1. Then I have log base 5 of y cubed plus log base 5 of y minus 7. Then log base 3 of 12 minus log base 3 of z. And then log base 7 of x plus 9 minus parentheses log base 7 of x squared plus 9. Oop, I ran out of space. Why don't I write this below C? It'll be easier for you to read. So this was log base 7 of x plus 9 minus parentheses log base 7 of x squared plus 10 plus log base 7 of 2 end parentheses. So try these out on your own. Pause the video here. You're just using our properties of logarithms above to collapse these into one. So your final answer should be 1 logarithm. And I'm going to go ahead and start going through these now. So pause it and work on these. But for part A, this is same base, and we have an addition. So we're using property number 6 here. So I'm going to collapse it into 1 by multiplying the 2 arguments, x and x plus 1. So this becomes log base 6 of x squared plus x, multiplying x times x plus 1. And that becomes the final answer for part A. Moving on to part B now. We still have the same basis. It's still an addition, so we're still using property 6. So we're going to be multiplying y cubed by the quantity y minus 7. So this is going to be log base 5 of y to the 4th minus 7y cubed, multiplying through. So that becomes our final answer. And for C and D, since I had to scribble that out, come down here. So in part C, it's log base 3 and log base 3, and it's a minus sign, so we're in property 7 here. So I'm going to take the first term argument and divide by the second term's argument. So this becomes log base 3 of 12 over z. That's our final answer. And then for D, trying to trick you a little bit here, since there's a parentheses here, we need to make sure that we distribute the minus sign first. So this becomes log base 7 of x plus 9 minus log base 7 of x squared plus 10 minus log base 7 of 2, distributing that negative. So now we go left to right. We collapse these first, and then we'll collapse it with this one. So left to right, we have a minus. So this is log base 7 of the top is x plus 9 divided by x squared plus 10 minus log base 7 of 2. And then this is log base 7 of x plus 9 over x squared plus 10 over 2. And when we divide a fraction by a fraction, we flip and multiply by its reciprocal, which is 1/2. So this becomes log base 7 of x plus 9 over 2 times x squared plus 10. And that becomes our final answer. Forgot a parenthesis there. Notice we also here could have done parentheses first and done x squared plus 10 times 2 and then divided x plus 9 over that, and we would have gotten to the same answer. So we could always work things a little bit different. But that is collapsing logarithms or condensing. In this next set of practice problems, we're going to do the opposite. So I'd like you to expand the following as much as possible. So if you're not sure if you're done, if you can still expand it into more logarithms, that means you are not done. So in A, have log base 7, 5x over 4. In B, have log base 3 of x cubed minus 9x squared. And then C will be a log base B of the square root of 3 over y. Oh, parentheses. A little crazy there. So again, you're basically doing the opposite of what we just did in the last set of problems. So try these on your own, pause the video, and see if you can expand it all the way out. So I'm going to start working through these now. So since I have a division here, I know I can write this as log base 7 of 5x minus log base 7 of 4. And then I have a multiplication here, so I can continue to expand and write this as log base 7 of 5 plus log base 7 of x minus that log base 7 of 4. And now I have just standard logarithms, base, argument, base, argument, base, argument. There's nothing else I can do. So this becomes my final answer. So that was for A. Now for B, I don't have any multiplications here, but we can get clever. And we're allowed to do algebra inside the argument of a logarithm. So I do notice that I have an x cubed and an x squared, so I can factor an x squared out and get x minus 9. So now I have a multiplication, x squared times x minus 9. And I can write this as log base 3 of x squared plus log base 3 of x minus 9. And now there are two ways to take care of this. We can see that this is x squared is x times x, and write this as log base 3 of x plus log base 3 of x plus log base 3 of x minus 9. And then simplifying this, we have two of these. So this is 2 log base 3 of x plus log base 3 of x minus 9. And so this is why we have this property, that property that we looked at that allows us to bring the exponent down, because we could have gone straight to here. But if you ever forget, just think of it as a multiplication. In either case, we get our final answer as 2 log base 3 of x plus log base 3 of x minus 9. And then in part C, this is a 1/2 power, so I'm going to rewrite this as log base b of 3 over y to the 1/2. And that's going to allow me to bring the 1/2 down to the front, 3 over y. Now, one thing to note is you can't do your division split until it's just the division. So if you have an exponent, you need to make sure you bring it down first. And then this becomes 1/2. Now the 1/2 is being multiplied by the whole thing, so we need parentheses here. Log base b of 3 minus log base b of y. And that becomes our final answer for that one. So I want to go through 2 more, but I'm going to walk through these together. We would in class, but I'm going to walk through these as an example. They're going to be slightly more challenging, and they're going to use every rule that we have. So we're going to collapse or expand the following. So the first one is going to be 2 log base 5 of x plus 1/3 log base 5 of x minus 3 log base 5 of x plus 5. So when we have multiple logs like this, we want to make sure we go left to right. So the first thing we need to do is start combining from left to right. Now, as I said a second ago, when you have your coefficients like this in front, we can't combine using our product to sum rule, what was that, property 6, until there's nothing but just log something, log something. So the first thing we're going to do is bring all of these exponents, or all of these constants, up as an exponent. So this becomes log base 5 of x squared plus log base 5 of x to the 1/3 minus log base 5 of x plus 5 quantity cubed. So now all of my logarithms don't have any constants, so I can start using my properties. Again, moving left to right. So we start with the first 2, log base 5 plus log base 5, so I can multiply. So this is log base 5 of x squared times x to the 1/3 minus log base 5 of x plus 5 quantity cubed. So I need to combine my exponents. Remember, we have the same base and we're multiplying. We add our exponents. So 2 is the same as 6/3. So 6/3 plus 1/3 gives me log base 5 of x to the 7/3 minus log base 5 of x plus 5 quantity cubed. Now I have log base 5 and I have minus a log base 5. So I can combine these into 1 using our division and difference rule. So it's log base 5 of, the first one becomes the top, x to the 7/3. The second one becomes the bottom, x plus 5 cubed. And so again, you'll know you're finished with these collapsing or condensing problems when you're left with one logarithm of a single base. Now, if you have multiple bases, we can't combine non-same bases. So if we had a log base 5 and a log base 2, those will never get combined. So that's another way to know you're done. But here, I have one logarithm, one base. I can't go any further than this. I'm done. I've simplified. So now let's look at another more complicated one. Log base 3 of x plus 5 squared over 3x squared. Whoops, that needs a parenthesis. So when you're told to collapse or expand, obviously your problem is going to dictate what you're doing. Here we had multiple logarithms, so it made sense to collapse it into one. Here we have one, so we're going to want to expand this out into multiples. So we'll always start with your division if you have it, because that's the big one. That's the big operation. So this log base 3 of x plus 5 quantity squared minus log base 3 of 3x squared. So I can bring this exponent down to log base 3 of x plus 5. And then here, whoops, not an equals, it's a minus. We need parentheses because the minus is subtracting the whole logarithm. So when I switch this out for log base 3 of 3 plus log base 3 of x squared, this whole summation, these two logarithms are equal to this. So we're not just minusing the first one, we're minusing the whole thing, which is equivalent to this expression that I have written here. So you got to make sure when you are expanding and you have a minus that you put parentheses so that you don't forget to distribute that negative somewhere. So this is 2 log base 3 of x plus 5 minus, now log base 3 of 3 is one of our properties. We know that this is equal to 1. And then minus, I can bring that 2 down. Log base 3 of x. And so our final answer, x plus 5 minus 2 log base 3 of x minus 1. Now, did I need to rewrite that with the minus 1 at the end? No, I didn't. Not technically, but it looks nicer to me, so I personally like to do that. And that would be our final answer. Again, you know you're done when you have no more multiplications or divisions or exponents inside the argument of the logarithm. So I have nothing I can bring down. I have no multiplications or anything I can factor here. I have no exponents to bring down. I have no multiplications or anything I can factor here. So I know that this has to be as expanded as possible, which it is. So the last thing we're going to do is kind of set up the next couple sections, and that is solving an equation, logarithmic equations. And these are two-step processes usually. So we're going to solve the following equation. And it's going to be log base 2 of x plus 3 equals log base 2 of x plus log base 2 of 36. So when we have a logarithmic equation, step 1 is always going to be collapse the logarithms as much as possible. Always step 1. So on the right side here, log base 2 of x plus 3 on the left, I can use our sum two products and multiply, so this becomes equal to log base 2 of 36x. And then I can subtract over the log base 2 of 36x. Log base 2, 36x. So this is going to give me log base 2, x plus 3 minus log base 2, 36x equals 0. So now I have a subtraction. They're both the same base, log base 2 and log base 2. So I can make this log base 2. First becomes the top, second becomes the bottom, equals 0. So why do we do this? Well, step 2 now is to convert to an exponential. That's an L. So if we convert this to the associated exponential, it's 2 is the base to the 0 equals x plus 3 over 36x. 2 to the 0 is always 1. So 1 equals x plus 3 over 36x. And now we're just solving this rational equation. So I'm going to multiply both sides by 36x. And we have 36x equals x plus 3 minus x. 35x equals 3. Divide by 35, divide by 35. We get x equals 3 over 35. Now the only thing we have to do is double check, since this isn't a polynomial, we don't have all real numbers as our domain. So we just have to check this number satisfies our domain here. So remember, inside of logarithms, that's just a number, so that's fine. Inside of logarithms, though, we have to be strictly greater than 0. So x has to be greater than 0, and x plus 3 has to be greater than 0. Those come from our two arguments of our logarithms. So these are our restrictions, and this means that x has to be greater than -3. And in both of these cases, we are satisfied. X is bigger than 0, and x is bigger than -3. So it's not a one or the other, it's an and here. We need to satisfy both of these inequalities. And we do. So we can box that up and call that our final answer. So that's the end of 12.6. Again, it's a relatively short one. The next couple sections we'll be doing more with logarithms and solving equations and introduce some applications and word problems.